All right, this is lesson 3 and 4. We're going to combine these two lessons. In fact, in lesson 4, we're actually not going to look at anything from that lesson. It's constructing different things with a bow compass, and we're not going to get into that into pre-cal. So just to let you know, when you do homework from lesson 4, and I'll remind you guys, in class, you will omit some from lesson 4. In fact, you will omit numbers 7 through 11. So we won't do 7 through 11. So basically our teaching is going to be from lesson 3 only, and we're going to look at some different things with triangles. We're going to look at Pythagorean theorem, and we're going to look at similar triangles using proportions to solve. So those are the two things we're really going to do in this lesson. First thing I want to jump into is Pythagorean theorem. I want to remind you what Pythag is. It is a squared plus b squared equals c squared, and you use this with a right triangle. There's got to be a right angle with the triangle. And so whenever you have a triangle that looks something like this, and you would get the right triangles right here, the side opposite the right triangle is called the hypotenuse. The hypotenuse in this case, for this example, we use the 3, 4, 5, which is a very easy one to do. And so what we say is 5 squared equals 3 squared plus 4 squared. So you put, with the formula being a squared plus b squared equals c squared, which you guys know this, c squared is the hypotenuse. It's always one by itself. So opposite the right angle. So we have 5 squared equals 3 squared plus 4 squared. 25 equals 9 plus 16. That's what they are squared. Then 25 equals 25. You can see how this checks out. That's one that you guys know. That is not a problem. But one of the things that we will kind of learn and look at in this lesson is when you have triangle inequalities. Where you have something like 7, they'll give you 7, 5, and 4, and they will ask you to figure out, is this triangle a right triangle, an acute triangle, or an obtuse triangle? And if it's a right triangle, then you'll get something like a squared. What you do is you square all of these, you put the biggest one on one side, and so you go 49 equals 25 plus 16. 49 equals 25 plus 16 is 30, 41. So what we found was that 49 doesn't equal 41. We found that 49 is greater than 41. So our c squared is greater than our a squared plus our b squared. That's what we found there. And so if you look over here, if our c squared is greater than our a squared plus b squared, we have solved for an obtuse triangle. And so these are the things that you can throw down in your notes or on your forward page to remember. But an acute triangle is when c squared is less than a squared plus b squared. An obtuse triangle is when c squared is greater than a squared plus b squared. And a right triangle is when c squared is equal to a squared plus b squared. You'll do a few of these in your homework lessons. The second concept that we're going to look at in this lesson is similar triangles. And this one we're going to look at 3 or 4 different examples. That way you really get a hang of this. What are similar triangles? What makes triangles similar? Well, triangles can be similar when their angles are equal. Let's put 2 triangles over here. One is obviously bigger than the other, but let's say this is a 30-degree angle, and the top one is a 30-degree angle. So if this is a 30 and this is a 30, this is a 90 and this is a 90, well, if 2 angles are equal, what we know about triangles is the third angle has to be equal. That's a geometry proof. We'll be working on that. It's actually something that is AA means AAA, which means if 2 angles are equal between triangles, the third one has to be, because this third angle has to be 60, because they add to 180 in every triangle. Now, even though one triangle is smaller than the other, they are still proportional because they are similar. What makes them similar is equal angles. But equal angles doesn't mean equal sides. It means proportional sides, which means you and I can use proportions to solve for the missing parts that we need. So what you always have to do in similar triangles is prove that the angles are equal, then their sides are proportional. And that proof takes you seconds every time that you look at it once you understand how this works. So let's look at this one that I've thrown up on the board here. And what we see here are, first off, these are attached to each other. And we see these little marks here indicating that these two angles are equal, which these two angles are equal because they're opposite each other. And opposite angles are also called vertical angles, and vertical angles and opposite angles are equal. So these two are equal. These two angles are also equal because they indicated it. They gave it to us by the way they did the tick marks. So what they gave us was these angles are equal and these angles are equal. So what must be equal are these two angles. They have to. Why? Because of that whole double A means triple A postulate. It's a geometry postulate there. So if we have similar triangles, then we can use proportion to solve. So what we need to do is get three ratios, and then we'll use those ratios how we want to. So what we have to do is use the sides opposite the equal angles are proportional. So, and if we're going to start with a certain triangle, let's say we're going to start with this triangle, then we have to start with it every time. So if we go with our ratios. So if we have 4 over y is one ratio, then we have to start with this triangle every time. So 4 over y, and then if you look opposite this angle, you have an x. The equal one is here, opposite this one is a 6. So we have to do x over 6, and then the other one is process of elimination. It has to be this one. 5 over 7. So these are our three ratios, and what we do is we can make a proportion to solve. Obviously, we will not go 4 over y equals x over 6, because that's two variables, and you can't solve for that. So what we're going to do is we're going to say 4 over y is equal to 5 over 7. So we only have to find one. Now with proportions, you cross multiply to solve. So you get 4 times 7, which is 28, equals 5y. Divide both sides by 5. And it's pretty typical in these problems to get fractional answers. So 28 over 5 is the answer there. So we've solved for y. Now we've got to solve for x, and we'll do it just right there. X over 6 equals 5 over 7. Cross multiply. 7x equals 30. Divide both sides by 7. X is 30 over 7. So we just solved for both with similar triangles. We're going to look at a few more of these examples. Okay, here's another example of similar triangles. This is a good one, and you really got to learn how to figure these out. Now, if you notice, they indicated that we have two right angles here. So we have one pair of equal angles. If we get a second pair, remember the third pair automatically goes with it. What would be another option would be these two guys right here. They're opposite in each other. Opposite angles are always equal. They're also called vertical angles. So that's that. That means the other ones have to be equal. So let's set up our ratios. I like to go left to right. So we'll get x over z is one of them. Okay. Then we have y over 8. And then the last one is 7 over 10. Now what you will notice is x and z is two letters that will always be in the same proportion. So that's going to be a little bit of a problem here. But what we do know is that these are right triangles. And if this is a right triangle, we can use Pythag to solve for z. So then technically we won't have another one there. And then we'll use proportions to solve for x and y. So we use Pythag to solve for for z. So it's 10 squared equals 8 squared plus z squared. 100 equals 64 plus z squared. Subtract 64 from both sides. Then we have 36 equals z squared. Take the square root of both sides. 6 equals z. So we've already solved for one of those. We can come up here in our ratio, and we can put 6 in that place. Now it's going to be really easy to use two different proportions to go ahead and solve for x and y. So we'll go x over 6 equals 7 over 10. 10x equals 7 times 6, so which is 42. We can go ahead and put that in there. Divide both sides by 10. X equals, I know you can put 4.2 as a decimal, but it's better to leave these as fractions because these are ratios or proportions. So if you just reduce, we get 21 over 5. So we'll leave it as 21 fifths. So we've got z and we've got x. Let's go ahead and get y. We get y over 8 equals 7 over 10. You get 10y equals 56. Divide both sides by 10. Y equals, once again, we'll reduce this one in half. It will be half of 56 is 28. 28 fifths. So we just solved for X, Y, and Z. But the whole big thing was we had to have similar triangles that they had their angles equal there. We're going to do two more types of examples, and they're all a little different, and that's the whole reason I'm going to keep going on these. It's the same concept, but just a little different style of going about it. Now what we have is a little triangle inside of a big triangle, and so it may be a little tougher for you to see it. If you need to draw it separately, if that helps you, then do that. I am going to just go ahead and take them from here. Obviously they share this angle. These two angles are equal, so these two have to be equal. So these are similar triangles. Now what's tough though sometimes to see is the big here is actually 10, not 4 and 6. It's 10 and 6 because you have to add these two together. So we'll have 10 and 6 right here. 4 and C are easy to see. And then right here you have A plus B and A. So those are all three. Now, so our ratios are going to be, if we go small to big, is going to be 6 over 10. It's going to be A over A plus B. And 4 over C. Same thing, we're going to need to do Pythag to solve for A. And so when you go ahead and solve for A, you get A squared equals 6 squared plus 4 squared. A squared equals 36 plus 16. A squared equals, that's 4652. So the square root of 52 is what A is, as you take the square root of both sides. So in place of A, I can now put root 52. And we'll go ahead, I'll solve for B. I won't do C here for you. You can do that very easily, not tough at all. I will say this, they did reduce the radical. We haven't done reducing of radicals, and that would probably be good to go ahead and do really quickly. If you break 52 as a radical down, you start with its prime factor. Start with 2, the smallest prime factor. Take 2, and you're going to go down to 36. Take 2, and you will go, that is not correct, 26. 2 goes down to 26, and then 2 goes down to 13. So these are all radicals, remember, because this is root 52, but it's root 2 times root 13. Any radical times itself is itself. So when you break down radical 52, it's 2 root 13 broken down. If this is something you guys need help in, I'll definitely work on that in class. Just let me know for each of you. So instead of root 52, you can remember that it is 2 root 13. But I'll go ahead and solve for B real quick, and I can do it with root 52 and then break it down at the very end. Makes it a little less writing. Make a proportion just like it looks. 6 over 10 equals root 52 over root 52 plus B. Cross multiply, distribute the 6. So, and we could go ahead and break down the radical if we want to now. It'd be 6 times 2, which is 12 root 13, plus 6b equals, and instead of root 52, it's 2 root 13, so we'll get 20 root 13 when you multiply the 10 times the 2. You'll add negative 12 root 13 to both sides. So we get 6b equals 8 root 13, because you only add the numbers in front when you add radicals. It's a lot like adding like terms. And then you divide both sides by 6. We will reduce to finish. 8, 4, 3. So 4 root 13 over 3 is B. So we solve for A, we solve for B, and then C you can solve for very easily. Nothing new there. This one probably is the one that is a little bit tricky, but it's no big deal if you organize it right in the beginning. The way that this is broken up, there's actually 3 triangles, and they're all 3 going to be similar, and you're going to need 3 different triangles to solve for this. And so I do recommend breaking this one up. And so you're just going to have to follow me here on how all this is going to work. First is the big triangle, okay? So let's redraw it like this. So the big triangle, and if you can kind of see big picture here, and I turned it and flipped it, but if you can see that visually in your head, I'm going to set the B on the bottom, you've got the A on the side, and then opposite this big right angle is 4 plus 8, which is 12. And so now I'm going to draw the two smaller triangles, and I hope they're not too small for you. But if you take this one, and then you flip it over, that's what I'm going to put over here. And this is going to share this angle with the big triangle. That's opposite the B, okay? So opposite this angle, and so you got to kind of bear with me, and that's what matters. So opposite is the B, and then opposite this angle that they share is the H, okay? So if the B is on the bottom, on the small triangle, the H has to be on the bottom. It's important that you do that. Opposite the right angle was the 12 on the big one. Opposite the right angle is the A on this little one. And then, of course, then you have the 4 left over, and it's going to go right here. So, same thing with this other little triangle. Now, this is a right angle. Make sure to draw that in so you know that. This other little triangle, B is the hypotenuse, which is opposite the 12 in the big one. Now, this angle here is shared with the big one. So that little angle is opposite the A. So that little angle, the H, is going to be opposite that. So if you got the A here, the H is going to be here. And then you have the 8. Okay, so that is how we kind of have all of these broken down. And then you get your proportions in order to solve for these. Now, we don't have a right triangle where we can go through what we need to do Pythagoras. We don't have enough there. But let's go ahead and solve for it. We could solve for 12 over A. Let's solve for 12 over A. So going from here to here is equal to, let's see, 12 over A is equal to A over 4. And so this allows us to solve for A. So A squared equals 48, square root of both sides. A equals root 48. Let's break down a radical. It's good practice. Breaking down a radical. 2 is 24. 2 is 12. 2 is 6. 2 is 3. When you end with a prime number, you are done. So we have two pairs of 2's that will come out. So because these are all radicals. Any radical times itself is itself. So 2 will come out. 2 will come out. So it'll be 4 root 3 is what our answer is for A. Solving for B, we're going to do the same thing what we just did. So these two triangles both have a B in them. So we'll go 12 over B. 12 over B equals B over 8. So 12 times 8 equals B squared. 12 times 8 is 80, 96. 96 is B squared. Take square root of both sides. B equals root 96. Let's break down our radical. 2 is 48, I believe. And then it's going to be the exact same thing. So it's going to be 4 root 6. I don't have to break that down. It's going to be 4 root 6 is going to be our answer there. I will just double check on that. That is correct. And then the last one that we'll look at is the H's, and you're going to solve the H's the very same way. I think you guys can handle that. That's enough on proportions. By the way, you guys are now ready to do lesson 4 for homework, because we just taught all that you need to know for lessons 3 and 4. Don't forget to omit the numbers that I said. Omit numbers 7 through 11. Those will not be required for homework, so makes it a little easier.